this is a video run through on all the skills you're going to need for your Unit 1 quiz. That is geometrical transformations. Those include translations, rotations, reflections, dilations, and a concept of what similarity versus congruency is. Okay? So up first is translations. And what is a translation? It's just this thing where you have to sort of slide shapes about in space. It doesn't change their size, it doesn't change their shape, it doesn't change their orientation. It creates a totally congruent shape that's just moved around in space. So we're going to go over this example problem. You're given this shape, triangle, translate by 2, -3. Translate by 2, -3. So what does that mean? It means take every point and go 2 to the right, because 2 is an x value, and 3 down, because -3 down down is negative in y, up is positive. You know, we've been here before. Okay, so 2 to the right and 3 down. And there's 2 ways to do this. I'm going to show you both of them. One way to do this is literally to start at any one point and say 1, 2 to the right, 1, 2, 3 down. And so this point, this original point A, will end up here at this new point A prime after being translated. See, this guy goes 2 to the right and 3 down. Here's the other way. Find the numerical coordinates of your original point. So here's the drill. Numerically, the way that we translate is we take the original coordinates of a point. I'm choosing this point, which I've labeled B. It's at 3, 2. And I'm translating it numerically by adding these values to my original values. So this is at 3, 2. It'll end up at 3 plus 2 is 5, so it goes to 5. And 2 plus -3 is -1. So I end up with this new B point right here. And what's really neat is that if I use this numerical method to get from 3, 2 to 5, -1, it's the same as if I did that other method where I literally just go 2 to the right and down 3. I get the same result, same point. It gives me this translation of this figure. If I do the same thing to this, 1, 2, 1, 2, 3, I have my C point, and I end up with a congruent shape that's just moved through space, 2 to the right and 3 down. We see how this triangle is the same. Yes? You see that that's the same thing. Next up is rotations. So rotations is literally just rotating a figure. That's kind of what it'll look like. So with rotations, you're going to be told, rotate this point about a certain point. Generally, you're going to be told to rotate about the origin. Okay? So that's what we're going to cover. Say that you're told to rotate about the origin. Let's say you're told to rotate about the origin 90 degrees in the counterclockwise direction. What you will do is literally rotate your page 90 degrees in the counterclockwise direction and ignore the fact that this is the x and that is the y-axis. Okay? Rotate your whole page, just do it like that. Then find the coordinates they would be if this were the orientation of your axis. So this point is at 0, 4. I'm going to write that down. This point is at -2, 2. I'm going to write that down. And this point is at -3, 1, 2, 3, 4, 5. -3, 5. Rotate it back to its correct orientation. Now, this is the trickiest part of this method. You have to read these numbers sideways, but that's okay. You will now put a point at 0, 4. 0, 4. But there's a point. You will put a point at -2, 2. There's a point. And you will put a point at negative 3 comma 5. 1, 2, 3, 4, 5. Ta-da! And you have successfully rotated your figure. And I'm going to draw it in with the correct orientation. I put this line in so you can see that it, see how it, oh, sorry. I put this line in so you can see that it's literally just where it would be if you rotated your page, so you might as well just rotate your page around that point. Cool? So, reflections. How do we do reflections? You'll be given a shape and you'll be given a line to reflect across. In this problem, we'll be reflecting across the line x equals 3. That line is 1, 2, 3 to the right of the origin, and it's a vertical line. Okay? So, x equals our verticals, y equals our horizontals. The x-axis is the line y equals 0. If you're told reflect across the line y equals 0, that is the x-axis. If you're told reflect across the line x equals 0, that is the y-axis. And if you're told reflect across the line x equals 3, that's a vertical mirror 3 to the right of the y-axis right here. Okay, so how do we reflect? Basically, what a mirror does is it creates a point that's equidistant on the opposite side. So, take this point and we count how far away it is from our mirror. 1, 2, 1, 2. Boom. There's our point. It's on the same horizontal line and it's equidistant away. 1, 2, 1, 2, there's a point. 1, 2, 1, 2, there's a point. 1, 2, 3, 4, 1, 2, 3, 4, there's a point. And you now have your reflection. So, dilations are by far and away the problem that people have the most difficulty with, I believe. You'll have something that says, dilate this figure about the origin by a factor of 3, or some other factor. Whatever the factor is, it's important. Pay attention. Okay. Here's your factor. Factor of 3. Here's all your points. What you're going to do is find the coordinates for every point and multiply them by the factor. So, for example, these points are at 2, 1, 2, 1, 4, 2, 4, 2, and 3, 4. 3, 4. And what we're going to do is multiply all these numbers by 3 and find our new coordinates. So 2, 1 is going to go to 6, 3 because 2 times 3 is 6 and 1 times 3 is 3. So this guy's going to go all the way over to 2, 4, 6, 1, 2, 3, and there's the new one. I'm going to put it in red. Okay, so I took each point and multiplied both of their values by 3. So 2, 1 becomes 6, 3, 4, 2 becomes 12, 6, and 3, 4 becomes 9, 12. And what I get is this similar triangle. It's not congruent, it's not the same triangle, but it's similar, which means that all the angle measures will be the same and all the proportions will be the same between these two figures. Cool? Cool. Okay, so that's it. Other than that, all you need to know is congruent, which means the same, and similar, which means similar, right? A congruent shape has the same side measurements, angles, that's about it. A similar shape has the same proportions and the same angles, and that's all you need to know. Okay, bye.